Okay, guys. Lesson 1.5 is we're going a totally different direction here, whether it be good or bad. Different direction today. Something called parametric. Oh my gosh. Parametric relations, and then also talking about their inverses. Okay. So before we go into that, we'll talk about what it means for a relation to be defined parametrically here in a moment. But for the moment, we're going to talk about implicit. If we have an equation that is implicit, okay, that's an equation that's not specifically solved and made y equals. So if I say like x squared plus y squared equals 9, that's an implicit equation because it's not a y equals equation or an x equals equation. Okay, if you have to put in a value and find the other value, it's not as easy to do because it's not already solved for that. So relations defined implicitly, where the relation, possibly a function, is not specifically solved for in terms of y. Now, using an implicit equation here, example 1 asks us to determine which of these ordered pairs are in the relation defined by the given equation. And then we'll talk, is the relation a function? So thoughts on how to decide if those ordered pairs are in the relation defined by x squared y plus y squared equals 5. Ross? Plug them in. We're in an ordered pair, you're given an x value and a y value. So if you take those and you plug them in, you are finding out whether they work or not. So if we try the first one, what's the first one?
2 negative 5.
2 negative 5. So if my equation is x squared y plus y squared equals 5, that means in place of x, I'm putting 2 times y, which is negative 5, plus y squared, so plus negative 5 squared. And our thing is, does this equal 5? And this was what? This was 2 negative 5 I was using, wasn't it? So 2 squared is 4 times negative 5? Negative 20. Plus, what's negative 5 squared? Positive 25? Negative 20 plus 25 is what? 5. Does 5 equal 5?
Well, yes.
It does. So what's that mean about 2 negative 5? It is in the, I'm going to say relation. We don't know if it's a function right now. Okay? But it's a relation because it's a set of ordered pairs. Okay? Let's try this next one. Again, using x squared y plus y squared equals 5. This time we're trying 1, 3. You guys don't really need me to work this all the way out, do you? This is a different route than the quiz, okay? I'm trusting that this is better than the quiz was. Okay, what happens? 1 squared times 3. 3 squared. So what do we end up with? Does 12 equal 5? No. So what's that say? Okay, 1, 3 is not in the relation. So now we have 2, 1. Then we're trying to put into x squared y plus y squared equals 5. So 2 squared times 1 plus, 1 squared. I'm messing my math up here. Let's see. 2 squared times 1 is 4. 1 squared? 1. And 4 plus 1?
5.
Does 5 equal 5?
Yes.
So this is the ordered pair 2, 1. Okay, so which of the ordered pairs are in the relation? And it was the 2, negative 5 and the 2, 1. 1, 3 was not in the relation. So now, The final question was, is the relation a function? Thoughts on is this relation is a function? Carolyn?
We know this 2x value or 1x value goes to 2 y values.
Okay. What ordered pairs happen to work here? 2, 1, and 2, -5. If you look at 2, 1 and 2, -5, which those are the two ordered pairs that happen to work, right? Notice the x values are the same, right? Those domain values repeat. And more importantly, they are paired with different y values. So is this a function? No. This is
Oh, yeah, it's not.
not a function, right? Because your x value repeats there. Here's what tells me it was most likely not a function. And I can't guarantee this, but often when you see a y squared in a problem, that's going to end up not being a function. Because if you solve for y, you'll end up having to take the square root to solve the equation. When you take a square root, you end up with a plus or minus. And so you have like y equals plus or minus something. So when you plug in an x value, you end up getting two different y values with it because you get the plus and the minus. Okay. We're okay with this, yes?
Yes.
No tricks right here. It's as easy as it looked, okay? Okay, now, name of the game today is these parametric relations. If a relation is defined parametrically, basically, there's a third variable involved. Not like in x, y, z where there's, a system has three equations. But where both elements x and y of a relation are defined in terms of a parameter. And that's that third variable, usually called t. Okay? So, for instance, as you look at this, like here's an example of a relation defined parametrically. They're telling us that x is in terms of t. X is t plus 1. They're telling us what y is in terms of t. Y is t squared plus 2t. Okay, so there's that third piece that is involved in a parametric relation. Okay, so x and y defined in terms of t. Now, we're going to look at this problem, and there's going to be several things we go through. And I believe, I forgot to pull the book and remind myself about the homework this morning, but I believe you have something similar to this in homework, where you're doing like these same type of questions. So, based on that parametric defined relation, A is find the points determined by when t is basically -3 through +3. So when it says find the points, realize you're going to be finding ordered pairs. We can find x because we have an x equation, and we can find y because we have a y equation. Let's see. Over to the right here, I'm going to set up a table. And so I'm going to kind of have 4 columns. I think I can fit this. My first column is going to be the t column because that's where I'm going to be, those are my values I'm going to be plugging in, yes? What are the t values we're given? Okay, -3, -2, -1, 0, 1, 2, 3. Now, one of the things we're going to have to do is we're going to have to find what x is. In order to find what x is, we're going to plug into t plus 1. So we're going to do that. Then my next column is going to be my y column. How do I find y? t squared plus 2t. So we'll plug into that. And then my third column, you could probably get away without doing the third column if you're out of room. But my fourth column, I can't count. is just my XY column, meaning where I'm going to express my answers as an ordered pair. So just kind of drawing attention to the fact that once you find an X and you find a Y, those can be put together as an ordered pair. Okay? So, what happens on the first one? If it says X equals T plus 1, what is T? Negative 3. And negative 3 plus 1 is? Negative 2. I didn't even catch what you said, so. Okay. We will eventually. Right now I'm talking a little bit about the work. Make sure everyone's on the right page here. We're all good. What about the Y? Again, we're plugging in. No.
Oh, sorry.
Plugging in. Negative 3. Okay, so you plug in negative 3. Negative 3 squared is 9. 2 times negative 3 is negative 6. 9 plus negative 6 is 3. So what's that make my ordered pair? Negative 2, 3. And this pen is dying on me. And of course, I don't have another pen the same color laying around that I can just fill in with. So I'm going to have to drive myself crazy and change colors in the middle of the problem. Although I might have another one in my bag. Okay, what are you guys doing with negative 2? Okay, plugging into the X equals T plus 1. Okay, so if you want, I'll show the work on this one, then I'll quit showing the work. Negative 2 plus 1 is negative 1. Same thing on the Y. What am I plugging in over here for T? Negative 2. You got it this time. Negative 2 squared is 4. 2 times negative 2? Negative 4. 4 plus negative 4? 0. So what's my ordered pair? Negative 1, 0. You got the idea of what we're doing, right? You had the idea of what we're doing a while ago. I'm not going to show the work on the rest of these. Let's just fill them in. For X, if we fill in negative 1 for T, negative 1 plus 1, 0. For Y, negative 1 squared is 1. 2 times negative 1, negative 2. 1 plus negative 2, negative 1. Makes my ordered pair 0, negative 1. Plugging in 0. I like 0. 0 plus 1? 1. 0 squared plus 2 times 0. There's the 0. Ordered pair of 1, 0. Okay, plug in 1. 1 plus 1. 2. 1 squared plus 2 times 1. 3. So this ordered pair is 2, 3. Plug in 2. 2 plus 1?
3. Oh my God. I'm done.
Plug in 2 on the Y. 2 squared plus 2 times 2? 4 plus 4 is 8. So ordered pair of? 3, 8. Plug in 3. 3 plus 1? 4. And 3 squared plus 2 times 3. So 9 plus 6, 15. Ordered pair of 4, 15. So that's not difficult work, right? I mean, be careful of your silly math mistakes, but not horribly difficult math there. Okay, that was part A. Are we okay with part A?
Yep.
By all means, please speak up if we're not for some reason. Okay, part B. Which was part B? Okay, part B. Find an algebraic relationship between x and y, and then is y a function of x? So, algebraic relationship. And I think I'm going to put my B work over here. We were given two equations, right? X equals t plus 1, and y equals t squared plus 2t. When we want an algebraic relationship between x and y, I want to take those two equations, and I want to eliminate t. We want to put them together so that t is no longer a factor. How can I take x equals t plus 1 and y squared equals t squared plus 2t and work with them to put them together so that we get rid of the t, so we only have x and y? Okay. So if we take one of the equations and solve for t, and then do what with that? Substitute into the other equation? That's exactly where I'm going with there. Now, obviously, I think obvious. Which one is easier to solve for t here? The top one, right? X equals t plus 1 is the one we need to take. So my step 1 here, I'm just going to kind of write it over here, is to pick one of your equations and solve for t. If it's x equals t plus 1, then I'm going to subtract 1, and t is going to be equal to x minus 1. Once I get that, what am I going to do with that? We're going to substitute into the other equation. So my other equation is y equals t squared plus 2t. So I'm going to write a note here to myself, and I'm going to plug t into the y equation. Guess I can move this up so you guys can see it a little bit better maybe. So, if I plug this in, what am I doing? Every place I see a t, we're replacing with x minus 1. And now I've put it in that bad spot that Levi can't see. Okay, so y equals t squared. So, what was t? X minus 1, quantity squared, plus 2 times t. 2 times x minus 1. You should work it out a little bit. What do I mean? Okay. Multiplying this out, so notice he said FOIL and distribute, because x minus 1 squared really means, for those that need the visual, x minus 1 times x minus 1. So first, x times x is x squared. Outsides and insides. Minus 1x. Another minus 1x. So if you don't mind, I'm going to go ahead and say minus 2x. And then minus 1 times minus 1. Try again. Nope. 1 times 1. Plus 1. The math mistakes are spreading. And so that was x minus 1 quantity squared, right? And by all means, write it out better if you need to. And then the 2 times x minus 1 becomes plus 2x and minus 2. Final cleanup. Y equals x squared. He says minus 1. Is that right? Yep. 2 x's cancel. Okay. So y equals x squared minus 1. That is our algebraic relationship between x and y. Now, along the way, it also asks, is y a function of x? In other words, is this a function? Okay, why are you saying yes?
Because I know that's just going to be a parabola.
Okay, y equals x squared is parabola. Minus 1 takes it down 1. And even if that minus 1 took it left or right 1, it's still a traditional parabola. It's going to pass the vertical line test. So, yes, this is a function. Right. So the other thing would be thinking about ordered pairs. Now, technically, in our chart over here that's off my screen right now, we did ordered pairs there, didn't we? And we just plugged the values in. But think about this. So we plugged this in. When we plugged t in to be 3, we got an x of 4 and a y of 15. Is there any other way you'd get a 4 here? Which thus, is there any other way you could have something else? And there's no like plus or minuses in this equation or anything. So it is going to work as a function. Now, can you graph this? Okay, part D is asking us to graph it. No, part C. I lied. Whatever part this is. And I don't know where I'm going to put this. I'm running out of room. Find a place you can put a graph. We've already talked about the graph, haven't we? I don't know how much of your Algebra 2 you remember, but the more Algebra 2 you remember in a situation like this, the easier this problem is. Okay? We can do this a couple of different ways. We can use the idea that Ross said, I know that's a parabola, move down 1. And you can graph it just like that. However, if that doesn't work for you, didn't we find some ordered pairs over here back in part A?
Oh, yeah, we can just plug those in.
Could we use those ordered pairs to graph it? Yeah. It's your call. Okay? What comes easier for you? So, now, I'm not going to worry about graphing 415. Honestly, I don't even think I'm going to graph 3.8. Yeah. Now, and here's what my brain works like. When I see x squared minus 1, my vertex is normally at 0, 0. The vertex moves down 1. Normally in a parabola, my first set of dots go over 1, up 1. And then my second set of dots go over 2, up 4. If you remember that, you can use that. Or you can plug the values in. So if I go over 1, up 1, over 2, up 4. Over 1, up 1, over 2, up 4. Guess what? I end up at the dots we have in our chart there. I have negative 2, 3, negative 1, 0, 0, negative 1, 1, 0, 2, 3. If you're real industrious, maybe you graphed 3, 8. If you're really, really industrious, maybe you graphed 4, 15. But, you know. Let's see. You signed in at the office, didn't you? I'm not going to mess with your attendance. They can change your attendance there. Just change it for my own records. Okay. Questions on that one? You got it?
Good.
Okay. I know Stella doesn't got it right now, but that's the problem with walking in during the middle of the problem, right? You'll get it later. Okay. Inverse relations and functions. A little bit of information before we flip to the backside and talk about this. If an ordered pair A comma B is part of a relation, then the ordered pair B comma A is part of the inverse relation. Okay, so notice If AB is part of the relation, then what happens with AB in the inverse? It becomes BA. Okay? Now, another piece of information here. If a function has an inverse, then it will pass what is called the horizontal line test. Just like the vertical line test, except horizontal. So what's a vertical line test do? A vertical line test tells us if something is a function. If it passes the horizontal line test, that says this function has an inverse. In other words, not everything is guaranteed to have an inverse. But if it passes the horizontal line test, it is. Okay, so same idea. Now, functions that have inverses are called one-to-one. Okay, think with me here. How do we know something's a function? It passes the vertical line test. How do we know if something has an inverse? It passes the horizontal line test. So how do we know if something is what we call a one-to-one function? If it passes both. Exactly where I was trying to get you guys to say. So if it passes both vertical and horizontal line test. Okay. We worked with inverses in Algebra 2, I believe. Okay, and the reason, because I feel like I remember talking about this. The inverse of a function, f of x, is written as, it looks like f to the negative 1 power of x, but that's f inverse of x. Does that part seem familiar? That's what makes me feel like, I feel like it was in Algebra 2, not, this isn't a first time experience on that. Yeah. Okay, now, this last part should maybe seem familiar, I think. To find an inverse function, x and y, switch, and then you can solve for y. Okay, and I feel like that's something we did in Algebra 2. Maybe not? I can't remember right now. So, to find an inverse function, you're going to switch x and y, and then solve for y. Now, don't know that I'm going to get through all of this, am I? Definitely not getting through all this, but we can do parts of it.
So will homework not be due till Friday?
Homework won't be due till Friday anyways because you guys have ASVAB tomorrow.
Oh, no. I do forget.
Wait, so for the ones that are going to be in here, will we need to bring our notes and stuff still?
I don't know.
Okay. Because there's
Okay.
like 4 of us.
I know. I don't know what I'm doing. Let me see where I can get here. Okay. Now, let's look at here. Which of the following graphs are A, relations that are functions? So A is asking us basically which of these are functions. And B is asking which of these relations have inverses. Okay. With that in mind, how do we know if something's a function? It's going to pass the vertical line test. So in order to be a function, vertical. How do we know if it has an inverse? Horizontal. Okay. So this is an easy part. Look at graph A. So graph A, question A. First of all, part A is this a function? Does this pass the vertical line test? Yes. So yes, it is a function. I'm just going to put a yes there because I don't have a lot of room. Part B. Does this relation have an inverse? So does it pass the horizontal line test. Does it work?
Yes.
Yeah, just like last time. So, yes, it has an inverse. What does that mean about graph A?
It means that it is a 1-to-1 function.
Okay, good. I saw several people looking back there. It is a 1-to-1 function. Did they ask that? No. Are we just talking about it? Yes. Exactly. We might as well talk about it while it's here. Okay, graph B, if you're okay with that. Is it a function?
No.
Okay, not a function because it fails the vertical line test. Now, we still have to ask ourselves, does this relation have an inverse?
Yes.
Does it pass the horizontal line test?
Yes.
Because, can you guys tell what's happening right here? There are horizontal asymptotes happening right here, yes?
Yeah.
And so, it is going to pass the horizontal line test. So this one is not a function, however, it does still have an inverse. Is it 1-to-1?
No.
No. Okay. What about this ellipse on part C?
No.
Is it a function?
No.
No. Fails the vertical line test. Does it have an inverse?
No.
No, it fails the horizontal line test. Okay. And D. Is it a function? Yeah. Because what's happening right here, guys? Here in between our pieces we have vertical asymptotes. Those don't prevent it from being a function. Everything else is good. So, yes, it's a function. Does it have an inverse?
No.
Going with a no there. Okay. That has to be my stopping point.
Yeah.
Okay, so I don't get caught in the middle of something. Now, technically, example 4 there is what we did last year. Now, granted, the part A there has a fraction, which makes life not as pretty, but that is what we did last year. If you want to go ahead and write down the homework, I'll tell you what the homework is, and it is on page 126, numbers 1 through 6, 9 through 12, 14 through 22, evens, 23 to 29. Now, I do have written on 14 through 22, no domains. So, I don't remember what that means, but don't worry about doing anything with domains. Okay? On the 14 through 22. Those of you that aren't going to be in here tomorrow, I may go ahead and finish these notes a little bit. So you might check on to Schoology later. Okay? And then Friday we'll probably talk about quizzes. I would be more likely to do quiz corrections than curve it. Because honestly the curve's not going to help the bottom right now. So